Hey, what's up? This is Jake, and we're going to go over Terraform Basics Part 3. So, what you see here is the public DNS of a load balancer, and if I refresh it, you can see the IP change to show that I've got two web servers running inside of a target group, and that target group is load balancing between them. And I have an autoscaling group that maintains two instances with a max of 3, desired of 2. And inside that autoscaling group, I am pointing this to a launch template that was created. And this launch template basically builds out my web server and has my key and all that stuff that you need, as well as some user data scripts. And that's pretty much it. So what I did was I started from the very beginning. We've been doing a lot of instances in the default VPC. So what we're going to go over is I'm going to destroy everything that I just made. Terraform destroy. And we're going to go from the very beginning. And there it goes. So, and go to the top. We've got roughly, well, not roughly, we have 179 lines of code to go over. So I'm going to try to make this somewhat quick. So rather than type everything out manually, I'm going to just show you what I did, and then I'll provide a link to my GitHub URL where you can download this and try it, or if you need a reference to say, hey, this user data script's not working because of base 64 encoding or something like that. I used, this is as of October 19th, so there's a lot of guides out there on the internet and a lot of things that are published, but they don't work because the AWS provider's been updated and Terraform's been updated, and so there's just a lot of hiccups and little gotchas, and so I went and solved all those. And the goal is to build a highly available cluster of EC2 instances hosting a web server that are load balanced and available behind a load balancer that you can provision uh, whenever you want and destroy it all you want. And it's repeatable infrastructure as code to build this very common scenario. So the first thing I did was I stuck my provider into just a provider file. Um, I might break these 179 lines up into different files. And I created a data file that grabs the AMI that's the most recent, owned by Amazon, whose name is Amazon 2 AMI HVM star, so whatever version, to make sure, because if you don't include this filter, you might get like an Ubuntu AMI or whatever. So to make sure it's Amazon Linux 2, I included this name filter, and it has an EBS root type, device type, and HVM for virtualization. Lastly, I put a script in here. I installed stress because I was doing some CPU stress tests on my instance, but this isn't really needed, so I can take this off for now. And just did a simple echo hello world from Nimbus DevOps at $hostname-f into my index file, so we can see when you refresh the web page which instance it's pointing to ensure that it is in fact load balancing correctly. So from there, I created a VPC. There's some defaults that, like instance tenancy by default is default, but I did add a couple things, but some of these are not required, but some of them are. I just created a CIDR block of 172 dot blah blah blah, enabled DNS support and host names, and then just tagged it with a name Terraform VPC. Pretty simple. I do put some space in between my resource creation when tags, just to kind of make the tags easy to read, but that's just a choice I made. For the next thing I did was, if you want your VPC to be accessible via the internet and have a way out, you need an internet gateway. So I went ahead and created an internet gateway. Very simple, and I just passed this VPC ID. So these internal references, you just need to include the provider with the module dot the name of the resource dot, in this case, the ID for the VPC ID. That way, whatever the VPC ID is, I don't need to go look it up. It'll just grab it from whatever this was when it was created. And again, a tag. So the next thing you need is a route table. So you've got routes in and out of your VPC. Kind of the same deal, just pass the VPC ID, pretty simple. And then I added a route. So I just said, hey, on this route table, destination anywhere, use the internet gateway. That's also pretty simple. Then what you need to do is you need to associate your route table with this VPC ID so that the route table is being used instead of the default route table of your VPC, which it will create one when you create a VPC. So in this case, I'm doing everything network, everything custom, just to show you how to set up a VPC without using default. And there's a lot of moving parts, so it's definitely something you should know how to do and understand how traffic gets in and out of your VPC, as well as what security is required. So the next thing is some subnets. So I created 3 subnets, subnet A, B, and C. They're all public because I'm working with web servers. And just gave them a CIDR block. So A has .0, B has 1.0, and then C has 2.0. And then I gave subnet A US East 1A, B US East 1B, C U East 1C, and map public IP on launch. So it has a public IP address. I was using that to do some testing. So and then just tag named them, right? So there's my 3 subnets. You should have 6. Once I start doing some backend stuff, I'll create 3 private subnets as well. And then you need to do route table association. So for this subnet should belong to this route table, and you do that for all 3. And then you do your security group, and I just named this allow HTTP, add a description, associated to a VPC, and then I just allowed from anywhere on port 80 for ingress, and egress is allow all ports, all protocols to anywhere. And if you're going to do all protocols, you have to use a -1, and if you use -1, you have to use from port 0 to port 0. That's just a rule for this provider. And then just gave it a tag. Next, you need a load balancer. So my load balancer is not internal. If you do an internal load balancer, it's not going to give you access to the internet. And the type is going to be an application. And then I just gave it the ID of my security group that I created, along with all 3 subnets. And I just created a list here because the subnet does require a string. If you just list these without the list brackets, it will tell you, you'll get an error saying that the data type string is required. And you can solve that by just sticking all 3 of these inside of a list. So the next is my load balancer should be pointing to a target group. So I need a target group. So I just made a target group real quick, pretty simple. And then you need a listener. So your load balancer can have multiple listeners, and these listeners just tell the load balancer itself, like, hey, I want you to listen on this port for this protocol, and then you give it a default action. So in this case, I said, listen on this port, and any requests you get on this port, just forward that to, and then I gave it the ARN of the target group. For the next part, I need to start actually building something. So I need an auto-scaling group. Now here's the tricky part. Most people in guides today on the internet, YouTube videos are using launch configurations. And if you go through AWS documentation, it's not recommended to use launch configurations anymore. It's recommended to use launch templates. And I found no shortage of problems in trying to get this to work. So in order to have an auto-scaling group, you need to pass it a launch template. So the first thing we need to do is create a launch template. So let me go over this. So I gave it a name, default version description, image ID. This is where I dynamically go to my data file and grab that AMI that I was talking about. And then instance type, key name, pretty easy. User data, If you do not, I tried using like end of file and then just putting my user data in here, but you get an encoding error. It can't parse that and it doesn't recognize it. So what you have to do is you have to put file base 64 for base 64 encoding and then pass it the path to a module. In this case, I'm treating this shell script as a module, and then I just stick all of my user data in this shell script. I just made this a little cleaner, but this part right here, it took me a while to figure this out and get that working. And then the next part created a lot of problems. So the correct way to get a launch template to work with an autoscaling group in Terraform is to add a network interfaces block and include the subnet ID, which is required, and the security group. And I just passed in the ID with a list because it needs a string. But here's the thing, this subnet ID, it doesn't even matter because what'll end up happening is your auto-scaling group has a VPC zone identifier, and you can include all of your subnets here, and it will grab one of these subnets. However, this is required, so you have to put something here, but it doesn't matter because when you deploy something, the auto-scaling group will dictate where it goes. So this gets overwritten. I don't like this. It seems like there should be um, a clause in here that says something like in network interfaces if subnet ID is not present, but auto-scaling group VPC zone identifier is present, then do not require subnet ID and network interface, but that does not exist, so you have to have both. I did a lot of testing, and that was the solution that I came up with. And then I just gave it a tag specification, so the instances have some names because I was creating a bunch of stuff and wanted to make sure I named it. You can do other things with names and make them random and put name prefixes and things like that, but I chose not to do that. So now you can create your auto scaling group, give it a name, tell it where it's going to be deployed, your desired maximum capacity, and then your launch template, and you just give the ID of the launch template that you created. And then I always just make sure it's using the latest version. So if I change something in here, it's not going to update my launch template. It's going to create a new version. So I want any instances that are provisioned as a result of a new launch template or whatever for them to use the latest version of the launch template. And then the last thing you need to do is you need to attach your auto scaling group with your load balancing target. So when it does provision that the resources, the EC2 instances it provisions are part of this target group, because your load balancer is pointing to the target group, and if your target group has nothing in it, then the load balancers, you're going to get a 504 error, or 502 depending on where it's at in the build process. So and then I just output the DNS of my load balancer, again, internal references, so that I can copy and paste that into my browser. This was kind of challenging, just because getting it to work, like going through the documentation for each thing is pretty easy. So in the registry, you would just look up AWS VPC and it tells you what the options are, what the parameters you can use, what the defaults are, whether they're required or optional, and what kind of values you can expect to pass, if there's any requirements, prerequisites, things like that. So you just check each one of these resource types. So your internet gateway, your route table, your routes, your route table association, subnets, et cetera, et cetera. So I destroyed my instances. So I should be able to go and see some terminated instances, which I do. As you can see, I've been doing this. I had like 16 instances yesterday. And this is working. The destroy is working. So I'm going to go ahead and do a Terraform plan so we can see what we're going to be building here. And maybe for fun, you could use the graph because this is a lot of stuff. So essentially, it's building everything, right? Because we don't have anything in existence right now. And if I wanted to, I could do Terraform graph pipe dot file type of SVG into graph.svg. And we could stick this in a graph.svg file. And then I can open up my repos, Terraform, ASG, Graph SVG, and this is what this looks like. So that is why I don't use the graph. It's incredibly complicated, but essentially what it's going to do is it's going to go through the providers, right? And then it's going to read in the output file, the load balancer, the autoscaling attachment, the route tables, the route table association, and my route. You'll see, internet gateway, route. There's like all kinds of these connections and stuff like that. And then the VPC. Now, all of these are dependent on the VPC minus the AMI and stuff like that. So you're going to see the VPC get built first. So this is kind of, it's a flow, but when we build it, you're going to see VPC gets created and then the internet gateway and so on and so forth, independent resources, then, dependent resources after that. So, and then the auto scaling group takes a little bit. The load balancer is going to take the longest because it's got to do DNS and all that stuff. But anyways, that's why I don't use the graph. Some people love it. When you get into this really big stuff, it gets messy. But ideally, what I would do is I would break this up and have the VPC be in one file, and then I would probably put my auto scale group, my launch template, and my load balancer in another file, and then maybe I would have my security stuff in another file, which will require a lot of internal references and external references. And it's something I can go over, but for now I just stuck it all in one file to make it easier, minus the script, the data, and my provider, which is something I tend to just do all the time. So let's go ahead and build this. So I'm going to use a Terraform apply, and you get to see this sucker in action. So it's going to go ahead and get me an updated state file. As you can see, it just changed. It's asking me to accept it. I'm going to say yes. And here we go. So we'll go ahead and check the console while this is creating. Since I have a lot of empty space, I'm just going to use my windows here to kind of watch both at the same time. And you'll see like VPC creation complete. So I should be able to go to VPC and see my Terraform VPC. Let's take a look. All right, there's my Terraform VPC, creating. It also says it made a route table. So if I go to route tables, I can see there's my Terraform route table. It created an internet gateway. There's my internet gateway. And let's see what else we got. Route table association. Let's go take a look. So here's my internet gateway associated with my VPC. My route table, actually, let's go look at the VPC and see what its route table is. So my route table is associated with Terraform route table. And then let's see, I got my internet gateway, and I have a load balancing target group. So let's go over to EC2 and check my target groups. We can see here's the target group, and there should be nothing in it. Yep, nothing in it. Total 2 targets. Great. Let's see, internet gateway, where was I at? Target group. All right, route table association. We saw that. Now we have a route. So there should be in my route table, we should be able to see a route. So I go to route tables, and then we'll go to Terraform RT and go to routes. And here's my attachment of my internet gateway to anywhere. So that's good. And then let's see here. There's my route. And now I've got my subnets. So I should be able to see my subnets. Sort by name. Terraform public subnet A, B, and C. Cool. And then I have my route table association with those subnets. So if I go to this subnet, for example, here's my route table association. So that's great. Let's see here, route table association. And now it's trying to create the load balancer. Its auto scaling group is complete. So let's hop back over to EC2. And we're going to go check our auto scaling group. Here's our auto scaling group. Desired 2, min 2, max 3. Great. Got my launch template, so obviously that's done. We can go take a look at that, make sure that's working. So here's my launch template. Cool. That's all fine and great. And then it finally finished creating my load balancer. So we can take a look at my load balancer. And there's my load balancer. It should have created a listener, which it did. And here's my listener listening on port 80 and forwarding to the Terraform target group. So that looks good. So now, and then my autoscaling group has been attached. So if I go to my autoscaling group, we can see what this is scaling to. And we have our launch template here. And then the load balancing is set to load balance in this target group. So then this target group is going to be fronted by my load balancer, and it's already created 2 instances for me. So if I go to my load balancer, and it looks like they're healthy, we can see this load balancer set up in 3 VPCs. It's got a security group, all the other attributes. Like I said, my load balancer rule is going to my target group, so everything should be good. I also added this output on my file to end, as you saw before, to get the DNS of my load balancer, which is here. So I should be able to just copy this and then paste that sucker. And once everything's done installing, as you can see in my script, it's got to go through yum update, and then it installs Apache, and then it echoes this into this file, and then it enables and starts Apache. And I've got hello world from Nimbus DevOps at the IP of 117. So if we go look at our instances, we can see there's 2 running. This first one has an IP of 117. The second one has .1.215. So this one is an availability zone A because I know it has a 0. And this one is an availability zone B because it has a 1. You can also just go scroll down and look at, where it's located and stuff. But I should be able to refresh this and see the different IP addresses change. And there you go. I'm just clicking it and it's going to hit one, it's going to hit another. So then what happens if you have an issue? So if I go to one of my instances, it's refreshing. All right, if I go to one of my running instances and I go to instance state and I just stop it, for example, and refresh, and you see it's stopping, I'm refreshing, and it's no longer going to that instance. It's just going to 117. So because they're in 2 different availability zones, we've created a high availability cluster of web servers, which is awesome. And if I were to stress test this sucker, I took it to 1 million requests to try to really, really flood HTTP requests to decrease the response time. And I had 0 problem with 1 million requests, and I think I only did like 10 concurrent requests. So what you should see now is we should get a new instance soon. So if we go over to the auto scaling group, well, actually, it's kind of neat to see in the target groups. So if we go over the target group, you're going to see that there's only 1 healthy target. We've got 2 targets that are required, right? So it's draining 1, and we got 1 healthy one, as you can see that here. So in our health checks, what it's going to look for is healthy is 5, but the unhealthy is 2 consecutive health check failures with a timeout of 5 seconds and an interval of 30 seconds. So if you need 2 of them, and one of them is 30 seconds, it's going to take a minute before it even registers. It knows it's unhealthy, like it says unhealthy 0, but it's just stopped, right? So it knows that it's not going to know for a minute until then that it needs to actually build anything. So then if I go to my auto scaling groups, we can go check out the logs here to look at the automatic scaling activity. Here we go, activity. So this is 1247, it's 1247 my time. You can see an instance was started in response to a difference between desired and actual capacity, increasing capacity from 1 to 2. So if I go to my instances, I can see that I now have this stopped instance and I have 2 running instances. This one's still initializing, and if I go to refresh, it's still only going to the first one because this other one hasn't been deemed healthy by the target group. So we can check the target groups and go, well, when am I going to get this sucker in there? So we can see it's unhealthy, health checks failed, it's still waiting. And if I go to there, it says health checks passed, no, initializing, still initializing, and it's only hitting 1. So the idea behind this is just that if you, you lose one, it's going to go ahead and create another one for you. So then the interesting question is, well, what if I start this, right? We're always like deleting things to test high availability. It says I can have a max of 3, but the desired is only 2. So now this instance state is pending while this is still initializing, and we're still only getting 1 instance. So for some reason, something went wrong with this deployment, and this ends up failing its health checks. It's entirely possible that, maybe that could happen for some reason, that you'd still have the second one here, and eventually it would just delete this one because your desired state is 2. So that's how you would deploy this environment using Terraform. If you have any questions, let me know. I know it's a lot of information. It took me like a whole day to troubleshoot all the problems and fix them while doing all the other stuff that I need to do. So, yeah, you can just leave it in the comments or reach out to me via email, whatever you want to do, and we'll go ahead and get you taken care of. So that's pretty much it. The next thing I'm going to do is probably do a bit of a deep dive on managing Terraform state, because that's something we haven't really talked about, and it's definitely something you'll see in the code as I've got lock files and state files and backup state files and all this other stuff. So yeah, we'll definitely take a look at Terraform state. But for now, that's pretty much it. I'm just playing with the load balancer now because it's kind of fun. But yeah, if you have any questions, let me know. If, like, for example, you need any help and you need to go look up like Terraform, AW, in any of my examples like AWS AMI, go in the registry, read through this data source. Here's an example usage. There's some regex stuff, like if you have your own AMI that you saved or something like that. And then you'll want to just make sure that you go through these attributes really well, nice and slow, read it completely, and just see, make sure it's exactly what you want it is. And you can just go through all of these data sources that I referenced in my main file. So like VPC, like I was saying before, Internet Gateway, and just make sure you understand what options are available, because maybe there's something you want to add that I don't have in here, and that's totally fine, and a normal thing to do. So, so that's definitely something you'll want to check out. I'm looking at my target group to see if any of these were put in there. It has 2. There we go. And we're back. So, yeah, once again, just let me know if you have any questions, but if not, then there you go. Hope this was helpful, and good luck building. Take care.